Welcome back to Summarize Science. Today, we are looking at a breakthrough in how computers design the world around us. Have you ever wondered how complex machines like scissors or car engines are actually designed? Usually, it takes a human engineer hours of clicking through complex software called CD, or computer-aided design. While AI has recently started helping with these tasks, it usually only makes static objects, like a simple block or a table. It has traditionally failed what researchers call the scissors test, which is the ability to create something with moving, functional parts. Existing systems simply couldn't model the joint that allows two blades to move in a slicing motion. A new system called AADvark is changing that by using an AI agent to act as the designer. This is part of a new variety of systems called agent-aided design. Think of it as a digital engineer that writes code, looks at the result, and fixes its own mistakes in a feedback loop. This diagram shows how the system takes a text prompt or an image and starts building the parts piece by piece. The agent creates JSON definitions for the parts and joints, and then sends them to a 3D assembly constraint solver. It doesn't just guess. It uses this solver to make sure the parts can actually fit and move together in the real world. One of the biggest challenges for this project was helping the AI understand 3D space, which is a known weakness for many models. To fix this, the researchers modified the design software to give every single face and edge of a part a unique color and texture. This visual feedback acts like a map, allowing the AI to identify exactly which side of a part it is looking at. Instead of just seeing a gray block, the AI can now say, attach the red side of the handle to the blue side of the blade. The researchers also upgraded the math behind the movement to use something called quaternions, which are much more reliable than standard angles for automated systems. By making these tools more AI-friendly, the system became much better at resolving its own errors. We can see the results here in Figure 2, where AADvark starts with a simple rectangle and slowly transforms it into a working pair of scissors. It successfully figured out how to make the revolute joint that allows the blades to open and close. The AI even spent extra time during its iterations to make sure the handles had proper holes for fingers. It is not just for scissors, though. The system successfully built various furniture items like a toddler bed and a chair. Each design started as a basic block and evolved through dozens of iterations until it matched the user's request. For complex objects like the toddler bed, the unique color coding was the key to getting the parts to line up correctly. Currently, the system is limited to using rectangular shapes and one specific type of joint. However, the researchers intend to expand the set of parts to allow the design of almost any object. This is a massive first step toward a future where anyone can describe a complex machine and have an AI build the blueprint. To recap, AADvark is a major leap because it introduces agent-aided design for dynamic objects with moving parts. By giving AI better visual cues and specialized tools, it can solve spatial problems that were previously impossible. This means that in the future, industrial manufacturing could become as simple as talking to a digital assistant. The ability for AI to reason directly about assemblies will likely change how we approach mechanical engineering. Thanks for watching Summarize Science, and don't forget to subscribe for more breakthroughs in technology.